Welcome back to the course on Data Science by Rob Fabric. Today, we're going to look at what machine learning is. So, in the data science lifecycle, we have learned all the different individual basic key components of probability and statistics, and now we're going to be applying those theories in our models and algorithms so that we can process the raw data that is cleaned and we can make a decision. There are several use cases of machine learning. Machine learning helps us rank pages in search engines. Based on the preferences of a person, the ranking of a page might be different in a search engine. For example, you can go into incognito mode and you can search up something and go into your normal browser and search it up. The difference in ranking is there. You can see a slight difference of ranking in the pages in the incognito tab when compared to your normal tab where all the browser history is there. Machine learning is also used to detect email spam. Email spam can be easily detected with machine learning and using naive Bayes, which we will be learning in this course. Machine learning is well used in image recognition. In Facebook, images are recognized by Facebook's algorithm to detect if the person is in your friends list by matching the pictures in their profiles. Now let us see a couple of applications of machine learning. Now, it is a known fact that there is a lot of data from the web click data, medical records, biology, engineering, and we can apply machine learning to understand these complex large data sets so that we understand what's happening in the data. Machine learning can be used to detect cancer cells in a patient. Applications that are not programmable by hand, such as autonomous driving, handwriting recognition, natural language processing, computer vision, can be done using the help of machine learning because coding these programs is closer to impossible. Also, programs like Amazon, Netflix, Hulu use the self-customizing program which is powered by machine learning to give you preferences of movies. If you watch a lot of romance or comedy movies, there's a good chance that Netflix or Hulu is going to recommend you a comedy romance movie. Now, we saw the applications and the use case of machine learning, but what is machine learning? The formal definition of machine learning is that it's a field of study that gives computer the ability to learn without being explicitly programmed. So in terms, machine learning is somewhere closer to a rule-based system, but the rules are not given directly to the machine learning, whereas the rules are learned by the machine learning from the data itself. The other definition is that computer program is said to learn from the experience E with respect to some task T and some performance measure P. If its performance on T as measured by P improves with experience E. Now let us look at the types of machine learning. Machine learning is split into three broad types. The first type is supervised learning. These are task-driven, where the independent variable and the dependent variable are given. The next step is unsupervised learning, where only the independent variable is given and the label, which is the dependent variable, needs to be identified. These are data-driven machine learning models. Next up, it is reinforced learning, probably one of the most fascinating machine learning concepts out there. The algorithm learns everything from scratch. The model is given no data or no labels. It learns everything as it grows based on a reward system. Now let us look at what supervised learning is. Supervised learning is task-driven. That means its job is to get from point A to point B. The input variables in a supervised learning are called X and the output variables are Y, and the function is Y is equal to f of X. The goal is to create a mapping function to approximately predict the new input data. So once the training is done, a fresh set of data is given to the supervised machine learning model and is expected to predict the Y from the X. There are two types in supervised learning. One is classification, which is for categorical data, and the other is regression for quantitative data. Here are some of the examples or models in supervised learning. In regression, we have simple linear regression, multiple linear regression, polynomial regression, decision tree regression. We will be covering some of these models in the later tutorials. Next, in classification, we have logistic regression, k-nearest neighbors, naive Bayes, and support vector machine. The other branch of supervised learning is neural networks, which we will also be covering in this course. Now let us look at what unsupervised learning is. As we talked about it, unsupervised learning only knows the x values, which is the independent variables. It is extremely data driven and is really useful for pattern recognition or pattern detection. Unsupervised learning is really useful to understand the demographics of the population, and it's really useful in dealing with large data sets. For supervised learning, we need to annotate the data sets, and annotation of data is really hard and it's time consuming. In unsupervised learning, you do not need to annotate your data, which saves time and money. Unsupervised learning also has an unknown class size. Now let us look at a technique called clustering, which is very well used in unsupervised learning. Clustering is a technique that combines different points of data into one by using distance-based measure. There are two main types of distance-based measure. One is Manhattan distance, the other one is Euclidean distance. To find the Manhattan distance, let's take 2 points, point P1 and P2. To find the Manhattan distance, we need to find the absolute value of the difference between P2 and P1's x value plus the absolute value of the y values of P2 and P1. In the given example, we find that the Manhattan distance is 7, whereas the Euclidean distance is the square root of the difference between the x values of P2 and P1 and the difference between the y values whole square. For the same problem, we get that the Euclidean distance is 5. Now, let us see an example for unsupervised learning. As we can see, we're using k-means clustering as one of the examples. We take raw data, which is unannotated, and then the final result is an annotated version. Using the distance clustering, the points will auto-assign themselves into different classes. Later on, we can name these classes to whatever we want. There are two types of clustering mechanisms in unsupervised learning. The first one, as shown in the example, is k-means clustering, and the next one is hierarchical clustering. Now, the difference between a supervised learning versus unsupervised learning is that supervised learning basically splits the data into two planes as shown in the image. One side is all of one class, the other side is the other class. Whereas in unsupervised learning, it forms into a cluster, and anything that joins this new cluster will automatically be assigned to that particular class. If a data point is in the middle of two clusters, the one which is the closest to the center of the cluster accepts this to be its new class or a new cluster. Now let us talk about reinforced learning. Reinforced learning is a model that reinforced learning is the training of machine learning models to make a sequence of decisions. You can think of reinforced learning like teaching a baby. You teach the baby to how to walk, how to read, how to write. In the same way, you can teach a machine or a computer to process information and do decisions based on that information over a time. The agent learns to achieve a goal in an uncertain and potentially complex environment. Each time you do a positive result in the environment, you are rewarded. That's when the machine learns this is a good step. Each time you do a bad move, you are subtracted in the reward or you're penalized. This is when the model learns that you have made a mistake. After running it a couple of times, the machine comes to a general understanding on how to handle the environment and how to play the game. Now let us look at one of the sampling techniques in reinforced learning. It is called Thompson sampling. There are 3 main steps. Step 1, at each round, which is each trial, you take 2 numbers for each actions. You take one action and then you see if the action yields a reward or does it yield a penalty. And this is usually denoted by 1 and 0, 1 for a good reward and 0 for a penalty. For each action, we take a random draw from the distribution below. The step 3 is we select the action that has the highest theta value. So we're taking the highest reward value and we're going to keep going forward in the environment. I hope this was informative. To learn more about machine learning and data science, please visit routefabric.com. Thank you so much.